Are you folks ready?
Yes.
Yes. I heard a no. I'll hold on about 4 more seconds. Are you folks ready now?
Yes.
Yes. That didn't sound very enthusiastic. Are you folks ready?
Yes.
Okay, more like it. Counting down from 3. 3, 2, 1. Now, this is an older Tesla coil. If we overuse it, it's prone to doing things like catching on fire. It's a little less than useful after it's caught on fire. So bear with me about 14 more seconds until I can zap it again. 3, 2, 1. Okay, I will zap it about 3 more times, but this is a museum. Part of my job is to tell you what you're looking at. This is a device called a Tesla coil. It was invented in the 1890s by Nikola Tesla to wirelessly transmit energy. The coiled portion of this device is a transformer. It's being used to raise the voltage. It's taking 240 volt electricity from the power grid, boosting the voltage so that the larger bolts have a voltage of about 500,000 volts. 500,000 volts. Another thing we're doing is we're boosting the frequency of the electricity. Let me explain what I mean by this. In our power grid, we use alternating current electricity. When you plug something in, one wire is positive, the other wire is negative at one moment. Next, negative, positive, positive, negative, negative, positive. The wires keep switching back and forth. We're alternating 60 complete cycles per second. The Tesla coil is taking that and boosting the frequency up to about 100,000 times per second. So you've got high voltage, high frequency electricity that allow those large bolts to come off the top of the Tesla coil. But it's also allowing for something that you do not see, something that interested Tesla even more. It's pushing out a lot of energy across the radio spectrum. Tesla envisioned building 200-foot tall versions of these across the country. You'd have an antenna on your roof. You'd receive that radio energy and use your appliances. There's some issues. This Tesla coil is 8 feet tall, and it's decently noisy. A 200-foot tall Tesla coil would be even louder. And because we use appliances like refrigerators 24 hours a day, 7 days a week, the big Tesla coils would have to operate 24/7. So imagine, it's 3 o'clock at night, you're trying to sleep, but you're hearing this only louder all the time. It would eventually get on your nerves just a little. So that's an issue. Some other issues. When you have bolts of electricity passing through the air, they tend to recombine oxygen molecules into ozone. And while ozone is wonderful when it's in our upper atmosphere, where it helps protect us from ultraviolet radiation from the sun, down here, ozone is one of the main ingredients of smog, something that we do not need any more of in LA. But by far the 2 biggest problems were that Tesla wanted to give electricity away for free. That's a hard sell to the power companies. And the biggest problem is that Tesla believed that he could transmit power farther out than he actually practically could. He bumped into a thing called the inverse square law. The further away you are from an energy source radiating out energy, the less power you'll get. So if you lived right next door to a big Tesla coil, you'd get a bunch of power. A couple blocks away, not so much. That having been said though, early radio was based a lot off of the Tesla coil, and while Tesla wanted a wireless world, he's responsible for a lot of wires in our lives. He designed the power grid we use here in the United States, and he also invented the alternating current electric motor that could translate that power into useful motion. Okay, 2 final zaps. The first of them, counting down from 3. 3, 2, 1. before the final zap, I have to cool it down for 20 seconds. Any quick questions?
When you press the button, the flash comes out from there.
When I push the button, the big flashes of light come out from there? Yeah, this button is allowing the voltage, the electricity to flow through the Tesla coil. So yeah, that's why it works. I'm pushing the button, yes. If there's any more to that, we can discuss, and yeah. Anyhow, final zap, counting down from 3. 3, 2, 1. Okay. Well, I hope you folks have a good night here at Griffith Observatory. If you have any questions, find a museum guide, ask us. Enjoy the rest of your stay. Thank you.